Hello and welcome to Controllers Tech. This is the 7th video in the AVR series using the explained mini development board, and today we will continue with the I2C master series. In the previous video we saw how to connect to the PCF8574 slave device, and control some LEDs in the output of the device. In today's video, we will see how to use the LCD1602 with the I2C. LCD1602 actually requires a minimum of 8 pins to be connected to the MCU, but with the help of the PCF8574 module, the pin requirement goes from 8 to only 2. We will see later in the video how the LCD is connected to the module, and how the module connects to the MCU. I have already prepared a library for the LCD, which uses the I2C master code that we wrote in the previous videos. Few months ago I released a video which shows how I wrote this library. The video covers the LCD functions, although it is made for a different MCU, but you should watch it if you want to understand this library. I used the same library across different MCU series, and it works without any issue. For example, here is the library for the STM32 controllers. You can see that it is exactly the same library. The only change is the I2C function that is used to send the data. Here in the STM32 library, I used the whole library function to send the I2C data, whereas in the AVR library, I am using the I2C write function we defined in the previous videos. The function takes the slave address, data, and the size as the parameter, and that is what we pass in the library. There is one more change in the library, and that is the delay function. Here is how the module is connected to the LCD. The 16 pins from the module connect to the 16 pins of the LCD, and the clock and data pins connect to the MCU. The data pin is connected to the PA1, and the clock pin is connected to the pin PA2. In this video I will only show how to use the LCD library, and as I mentioned, if you want to understand how the library was written, please watch the video linked in the description of this one. We will continue with the same project which we used in the previous video. Let's copy the LCD library files to the project folder. Now we need to include the existing items to the project, so include the header file and source file in the respective folders. I have already added the necessary inclusions like the AVR IO header file, and the I2C master header file. Now let's use the library and send some data to the LCD. Include the I2C LCD header file in the main file. If you check the LCD initialization function, here you can see the I2C is already initialized in it. Let's add a delay of 100 milliseconds, so the I2C can initialize properly. Now remove the I2C initialization from the main function, and we will add the LCD initialization function here. Now let's prepare the data to be displayed on the LCD. I will send these two buffers. The LCD put cursor function is used to put the LCD cursor at a specific location. For the LCD1602, we have the two rows, 0 and 1, and 16 columns, 0 to 15. Let's put the cursor on the 0th row and 0th column. To send the data, we can use the LCD send data, which is used to send a single character to the display, or LCD send string, which is used to send an entire string to the display. We can send the buffer we defined above, or send the string directly. Now let's put the cursor at the beginning of the next row, and send the buffer to this position. Alright, let's build the code now. The LCD send string function takes the character pointer as the parameter, so let's change the buffer type here. We don't have any errors, so let's flash the code to the board. Here you can see the LCD is displaying the data as we programmed it to do. Now let's change the string and flash the code again. You can see the new data on the LCD. So the strings are working fine, we can display them to the required positions as needed. Now let's see how to display the numbers on the LCD. Let me define a number, and a character array where the number will be stored in the character format. We can't send the number directly to the display, so we will convert each digit of the number to character format, and then display the characters. The function sprintf does exactly this. Let's define this number as the 16-bit unsigned integer. The format specifier U converts the unsigned integers to the respective characters. Let's include the standard I/O header file for the sprintf to work. After the number has been converted to character form, it's stored in the number array. Let's send this array to the LCD. Now build and flash the code to the board. Here you can see the number printed on the second row of the display. The LCD send data can be used to display a single character to the LCD. Also, if we don't set the cursor position, the new data will display at the very next position on the LCD. Here I am sending the character A, without setting the cursor position. You can see it got printed on the LCD very next to the number. The cursor on the LCD automatically increments by 1, and if we don't specify the position, the data will print just next to the previous data. We have only a few functions in the LCD library. There is the initialization, sending string data, and the clear function. Let's use the LCD clear function now. After writing the data, we will wait for 2 seconds, and then clear the LCD. Let's build and flash it to the board now. So the data is printed on the LCD. Now after 2 seconds, the display gets cleared. So we got the LCD to work with the AT-Tiny817 MCU. If you want to understand the library, please check this video. The link to the video is in the description below. We will continue the I2C master in the next video also, and finally we will see how to read the data from the slave device. This is it for today. You can download the code from the link in the description. Leave comments in case of any doubt. Keep watching, and have a nice day ahead.